Imagine combining a weather API, calendar service, and other microservices into a single unified endpoint, without writing custom integration code for each one. You'll see how FastMCP's multi-server proxy configuration lets you mount multiple remote MCP servers under one roof, automatically prefixing their tools, resources, and prompts so they never collide. The pattern is simple. Define your backends in a config, and FastMCP handles the rest.
Hash multi-server configuration. Config equals MCP servers. Weather. URL. https://weather API example com/MCP. Transport. HTTP. Calendar. URL. https://calendar API example com/MCP. Transport. HTTP. Hash create a unified proxy to multiple servers. Composite proxy equals FastMCP. As proxy, config. Name equals composite proxy. Hash tools, resources, prompts, and templates are accessible with prefixes. Hash tools, weather get forecast, calendar add event. Hash prompts, weather daily summary, calendar quick add. Hash resources, weather, //weather/icons/sunny calendar, //calendar/events today. Hash templates, weather, //weather/locations/ad calendar, //calendar/events/date.
This demonstrates the composite proxy pattern for unified access to distributed services. The configuration defines multiple remote servers as a single logical unit, creating a facade that merges their capabilities under consistent naming conventions. What makes this distinctive is how it preserves each backend's isolation while presenting them as a cohesive system to clients. The pattern works by establishing a naming hierarchy through prefixes, where each backend's components, tools, resources, prompts, are automatically namespaced under their server identifier. This creates a clean separation between services while allowing clients to interact with them through a single connection point. The proxy handles all routing and transport bridging transparently, letting you compose systems from heterogeneous services without tight coupling. This approach solves the problem of service fragmentation in distributed systems. Instead of managing multiple connections and inconsistent APIs, clients interact with a single endpoint that normalizes access patterns. It's particularly valuable when integrating legacy systems, microservices, or third-party APIs where you need unified access without modifying the underlying services. The trade-off is slight latency overhead from the proxy layer, but the simplification often outweighs this cost in complex architectures. Let's break it down line by line.
Hash multi-server configuration. Config equals.
This defines the multi-server configuration dictionary, centralizing connection details for all MCP servers. The structure standardizes how each server's URL and transport protocol are specified, enabling consistent proxy creation across different services.
MCP servers.
This defines the MCP server registry, a dictionary mapping logical server names to their configurations. It enables the composite proxy pattern, letting you route requests to different backend services through a single unified interface.
Weather.
This defines the weather server entry in the multi-server configuration. Each key under MCP servers maps to a distinct backend service, enabling the composite proxy to route requests to the correct API endpoint. The structure follows FastMCP's standard multi-server pattern for unified access to distributed services.
URL. https://weather API example com/MCP.
This defines the endpoint URL for the Weather Services MCP interface. The URL specifies where FastMCP will route weather-related tool calls, ensuring requests reach the correct backend server. This follows the standard MCP configuration pattern, where each service gets its own dedicated endpoint.
Transport, HTTP.
Specifies the communication protocol for the MCP server connection. This ensures the proxy uses HTTP for all requests to the weather and calendar APIs, standardizing how data is transmitted and received. This closing brace terminates the calendar server configuration object. It maintains valid JSON structure, ensuring the config remains parsable while separating distinct server definitions.
Calendar.
This defines the calendar server configuration entry, mirroring the weather structure. The consistent key-value pattern enables FastMCP to dynamically route requests to different backend services while maintaining a unified proxy interface.
URL, https://calendar API example com/MCP.
This defines the calendar server's endpoint URL. The MCP protocol requires explicit server locations for each service, enabling the proxy to route requests correctly. This follows the service discovery pattern, where each capability has a dedicated, addressable endpoint.
Transport, HTTP.
Specifies the communication protocol for the MCP server connection. HTTP is the standard transport for res-TFL APIs, ensuring compatibility with most web services and load balancers. This field supports other protocols like WebSocket or gRPC when needed for real-time or high-performance scenarios. This closing brace terminates the calendar server configuration block. It maintains proper JSON structure, ensuring the config remains valid and parsable by FastMCP's proxy system. Without it, the composite proxy would fail to initialize due to malformed configuration. This closing brace terminates the nested MCP server's configuration dictionary. It maintains proper JSON structure, ensuring the config remains valid for FastMCP's proxy initialization. Closing brace terminates the config dictionary definition. This completes the multi-server configuration structure that will be passed to FastMCP as proxy. The nested structure enables unified access to multiple MCP servers through a single proxy.
Hash create a unified proxy to multiple servers. Composite proxy equals FastMCP as proxy config. Name equals composite proxy.
This instantiates a composite proxy that unifies multiple MCP servers under a single interface. The configuration object defines each server's endpoint and transport protocol, while FastMCP as proxy handles the routing logic transparently. This pattern eliminates the need for manual server switching in client code.
Hash tools, resources, prompts, and templates are accessible with prefixes. Hash tools, weather get forecast, calendar add event. Hash prompts, weather daily summary, calendar quick add. Hash resources, weather, //weather /icons /sunny calendar, // calendar /events today. Hash templates, weather, // weather /locations /ad calendar, // calendar /events /date.
This demonstrates FastMCP's namespaced resource addressing pattern. Each server's tools, prompts, resources, and templates are automatically prefixed with their server key, preventing naming collisions in composite setups. The URL style syntax enables hierarchical organization and dynamic path resolution. Composite proxy pattern. The multi-server configuration in FastMCP 2 creates a unified interface where each server's capabilities are namespaced under its config key, enabling seamless cross-server tool and resource access. Prefix collisions silently fail, so ensure server names and component names don't conflict across your configuration. This approach transforms disparate APIs into a single logical endpoint without modifying the underlying servers.
The proxy that knows no server becomes every server.